So of course, naturally, someone might already wonder why would we be talking about mathematics and juggling? Well, no, I'll read this for you. No, it's true. Actually, juggling and mathematics enjoy a surprisingly intimate relationship, and you'll see that hopefully by the end of the day. We're going to talk about a few things today. First of all, site swap notation, which is the typical notation that jugglers use to speak about juggling patterns, and a few objectives for you today. Hopefully, you will understand what the pattern 4-5-1-4-1 means, and 9-1 and 5-4-3-2-8-9. Okay, you're gonna be able to understand juggling sequences. You're going to know some basic site swap theorems. We're also going to talk about juggling states, which is another way of talking about juggling patterns. And juggling states are just landing schedules for when the balls are coming in. And then we're going to see how they're used to find site swaps, juggling patterns. If we have some time, this is already going to take a long time. Let's do the first two. We're going to talk about synchronous juggling patterns. Normally we talk about juggling patterns right, left, but instead right, left. And then maybe we'll talk about my research. But I figure if we have time for that, then that'll be nice. But I wanted to make sure you understood, because there are a lot of people here that don't have a strong mathematical background. And I'm so steeped in this juggling of mathematics that I know everything. I don't know all the prerequisite information so well. Like, I naturally think that everyone understands it. So I'll touch on what I'm doing, and if you want to know more in depth, you can read my paper, you can come and talk to me or something like that. First of all, just to throw this up here, this is kind of fun. If we had time, I'd love to show you this program. This is called Juggling Lab, and just because a lot of jugglers are mathematicians and computer scientists, there are lots of programs like this out there that do simulations. So for me, that's nice, because if I want to see a 20-ball pattern, which humans can't do, I can have a computer do it. That's Peter Brubeck. So what is site swap notation? Well, site swap notation was invented simultaneously, we're not really sure who to give credit for. Right around 1985, 3 groups of people, independently, in different locations, developed the same kind of idea, using slightly different ways of phrasing it, but all came up with the general idea. And so we credit it to all 3 groups that are listed there. And it looks something like this, just so you're familiar with what site swap notation looks like. We're going to explain it in a second. But as I said, those are some examples of what site swap will look like. And we know what that means when we juggle these patterns. They're all different. So before we start, we have to lay down some ground rules, and these are kind of the rules of the juggling game. For now, we can break the rules later. But first of all, the juggler must juggle at a constant rhythm. Right, left, right, left, right. At a constant rhythm. And of course, this is kind of idealized juggling, right? Of course it is, because we're talking about mathematics. The pattern juggled must be periodic. It must repeat over and over again, right? Okay. And you'll find out more what that means in a little bit here. Another thing is that only one throw may occur on each beat of the pattern. Now, as I already said, we're going to talk about synchronous juggling, and so I'm telling you that eventually, if we get to talking about synchronous juggling, we're going to break that rule, because we're going to do patterns like this, right, where you're throwing 2 on the same beat. Well, for now, we're not going to talk about that, right? Because we want to talk about patterns that are juggled 1 beat at a time, 1 throw on each beat. Other patterns that violate that rule are patterns like this that have a multiplex throw in them.
Oh.
Right, where two balls are being thrown at once, right? So these are the rules. We're not going to do any of those things, even though they're possible.
Gee.
Okay, so now for 3 balls, for instance, I'm going to put a blue one in here just so you can see this. If we count out the beats 1, 2, 3, 1, 2, 3, 1, 2, 3, one of the balls, we'll say the blue ball, just so we can see it, will be thrown on 1. Every time I say the word 1, it should be thrown. Just based on your intuitions, right? Hopefully that's happened. And then the other ball, the white ball, and then the white ball will be thrown on 2 and 3 respectively, right? So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2. Right? That makes sense. Hopefully that makes sense, right? That's pretty intuitive that would be happening. And of course, one thing we not want to notice is that it's going from the right hand to the left hand. So a 3-ball throw is a throw that lands 3 counts later, or is thrown again 3 counts later, from the opposite hand that it was thrown from. Okay, so now with like the 4-ball pattern, we're going to do the same thing. But this time I'm going to count 1, 2, 3, 4. The blue ball being thrown on the 1 count, the white ball, and the white ball being thrown on 2, 3, and 4 respectively. Okay. And that looks like this, right? 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 2, 3, 4, 1, 2, 3. Right?
Right.
Now in this case, you probably even noticed that the blue ball was being thrown every 4 counts, but that made it go up and down in the same hand. I don't know if you noticed that. Did you catch that? The blue ball, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. It's always in the right hand. Right? I don't know if you noticed that. So I asked you to guess the rule. What would happen if I tried 5? Someone, what do you think? What do you think would happen if I juggle 5?
Use the foot.
I use my foot, yeah, because I don't have enough hands to juggle 5. That's impossible. No. If one was to juggle 5,
Count of 5.
we'll see what
Count
happens.
of 5.
You're going to land every 5 counts, and is it going to be in the same hand or the opposite hand?
Opposite hand.
It's going to be an opposite hand, and that's a good intuition. It looks like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right? At any point, you're also like laughing. Release it with a little clapping. That's fine. So what's the rule? If I were to do 6, what would it be? You know, it would be basically 3 in each hand. Every 6 counts, it would return to the same hand. So what's the rule? What's the rule? What else? Like we could guess 7 and 8 and 9. What rule are we operating by here? Does anybody want to take a guess what the rule is? Anyone?
Even throws,
right?
same
all,
hand.
Right. Yeah,
Odd throws.
All odd throws land in the opposite hand. Those are called cascade throws. Jugglers call them cascade throws. And fountain throws are throws that are same side throws, even numbered throws. Now, of course, this is assuming this doesn't what we just talked about there. This intuition about crossing and uncrossing throws is, of course, based on the fact that we have 2 hands. That's why that happens, right? Because we're juggling right, left. So an even number puts it right back because we're mapping it to an even number of hands, right? This would not hold, of course, if you used the close. Used 5 different hands to juggle or something. Now, after this slide, you will understand how to read sight swap notation. Consider a pattern in which the balls are being juggled in the following sequence. 5. I'm making a 5 throw, just the kind of throw I was just talking about, a throw that is thrown again 5 counts later. Then a 3 throw, then a 4 throw, and then a 5 throw, and then a 3 throw, 4 throw. And this is a simple juggling pattern. It obeys all the rules. I'm going to make this on an even rhythm. 5, 3, 4, 5, 3, 4. I'm going to do it periodically. 5, 3, 4, 5, 3, 4, 5, 3, 4, over and over again. And what's the other rule? Oh, I'm only making 1 throw in each beat. Okay, and this is what it looks like. 5, 3, 4, 5, 3, 4, 5, 3, 4, 5, 3, 4, 5, 3, 4, 5, 3, 4, 5, 3, 4, 5, 3, 4, 5. You can see, I don't know, and hopefully you'll have a better understanding of how to see what I'm doing eventually. You'll gain some understanding of that. This pattern is called 5, 3, 4. And we, of course, use the minimal representation because it's periodic. We don't have to call it 5, 3, 4, 5, 3, 4. That's kind of redundant. So we use the minimal period to talk about it. So the sight swap, this is your understanding right here. The sight swap is simply juggled as a sequence of the throws we're talking about, right? From left to right, just like you would read, right? I'm going to make a 5 throw, then I'm going to make a 3 throw, and then a 4 throw. And then, so when you see the pattern 4, 5, 1, 4, 1, for instance, which I talked about at the beginning, that told you you'd be able to understand. Well, that's just a sequence of throws. 4, 5, 1, 4, 1. Repeated. 4, 5, 1, 4, 1. That's what it's going to look like. Now, before we go too much further, I want to make it clear how one juggles 1 ball and 2 balls, maybe even 0 balls. First of all, 0 balls looks like this. 1 ball looks like this, right? It's an odd number, so it has to cross. Every beat, I'm making a throw. 2 balls looks like this. Okay, this is the tricky one, because people don't think of 2 balls looking like this. But this is a complex sight swap, okay? This is how 2 balls is juggled. Right? Even number split across the hands, 1 in each hand. Even tempo, right? This is a sight swap. It's called 3-1, actually. Okay? 2, 2, 2, 2. Right? Just some prerequisite information so you understand what some of these juggling patterns, because a lot of them will have 1s in them. And you'll see that that's a throw that the very next throw, if if I threw it from the right hand, the very next throw is going to be with that ball from the other hand. You know, that's a one ball throw, right? Zipped across. So some common side swaps here. Some three ball side swaps, for instance. Here's 4-4-1, and again, try and see if you can see the kind of the structure of the pattern based on. Huh? Yeah, it's yeah. I'll use three different colors. It's not the balls. The balls themselves are not going to have a repeating pattern. The period of their repetition isn't going to be 3. Just the throws I'm making are going to have that repetition. You'll see why. It's not like one ball is doing the 4-ball throw and one ball that kind of thing. So see if you can see the structure of the pattern based on the way we talked about that. The 4 throw, the one throw here. 4-4-1. As a 4-4-1. I try to do it slowly so you can kind of see it. 5-3-1 looks like this. Now this one, actually the 3 ball does get isolated. I'll use the white one here. 5-3-1, 5-3-1, 5-3-1. That's 5-3-1. And then 4-5-1, 4-1, which is the one I talked about earlier. That isolates the 5 ball actually. So and it looks like this. 4-5-1, 4-1, 4-5. Here's some 4-ball side swaps. 5-5-5, 5-5-5-1 is a common one. Looks like this. Some people consider it like a 5-ball warm-up because it's almost the 5-ball pattern, except we got this whole pass across underneath. You can see that one, a 1-ball throw underneath. 5-3, looks like this. Six, 5-3-4, the one we already did, looks like this. 5-3. And 6-3-3 looks like this. And 7-1 is of course the 4-ball shower, which looks like this. Now some 5-ball side swaps. Now this is a little more complicated because they're harder. So here's 7-4-4. Looks like this. 1 second. I don't know if you can see, it doesn't last long, sorry. Should use 5 on it. I don't know if you can see that a little bit. 6-6-6-6-6-6-6-1 looks like this. Seven five 7-5-1. I'm only going to do a one-off. I'm going to go 5-5-5-5-5-5-5, 7-5-7-5-1. 5-5-5-5-5-5. 7-5-7-5-1. Here comes again. This time for real. 7-5-7-5-1. Just for your information, man, we're already running short on time here. just so you know what a site swap is. As I said, you already know how to read site swap. But just for your information, what site swap really means, the word site swap, is it really just we're swapping the landing site of two balls. What their landing site was, we're taking them and switching them. So for instance, in the 4-ball pattern, if we just concentrate on 2 throws, the ones I have highlighted for instance,